Hello, this is Hamad at Microsoft Group. Today we are going to work on a 2D analysis of some water crossing a pipe. First of all, please subscribe our channel, like our video, and turn on the notification to let us be your guest on your home and learn many Ansys fluent points together. As the first step, I will drag and drop fluent right here to this place. Here we find fluent, and after right click on geometry, we will go for letting the software know about the shape of our problem. I will click on this one, new design modeler. So this is a new version added to Ansys. I most of the time do not use this one. I use SolidWorks and Invertor and Katia instead. So for simple 2D design, I will just use this one, and I'll wait until it pops up. As far as this one is red, you cannot do anything. Just wait until your process finishes. This is where we can design anything we want. I click on the Z and go to units. I change the units to millimeters. I will go to XY plane to draw my sketch. Click on it, go to this one, new sketch, and after clicking on this tab, you will see some tools right here by which you can model anything you want. Our model is a pipe. The diameter is 20 millimeters, the length is 100 millimeters, and the internal velocity is 0.0005 as the velocity. I click on the rectangle because we want a 2D model of our pipe. I draw a rectangle. I go to dimension tab right here. I choose general. It has different kinds of dimension, different kinds of tools you want. I click on general, click on the both of the dimensions right here. H1 is the length, so I change it to 100 millimeters, and as the internal diameters, I will choose 20 millimeters. Right here you have the rectangle you want, and the next step is to go to concept right here and choose surface from a sketch. It will ask you to choose a sketch. I choose this one, sketch 1, and click on apply. After clicking on apply, you will have to click on generate to see the surface you are going to make. We have to make a surface because the meshing is only on a surface. You cannot do it on a sketch, as you can see. The next step is to clicking on this one, this plus, and click on surface body to change our type to fluid. As you can see right now, this is a fluid part. The software recognizes this part as a fluid, and right here we close the modeler, and the next part I will update this one and we'll go to mesh. Right click on it and press on edit. As you can see, once again this is red. We have to wait until it pops up. We wait. In this part we are going to have mesh on the model. This is the model you can see. First of all, we click on generate because because it is in a default mode and it will give you a mesh. After clicking on it, you can see it. The number is really not okay. As you can see, the size of the elements are so high, and this is not called a good mesh. So we have to change the size of the elements. Right here in the mesh, you can see here there is a tab called sizing. In sizing, you can right here in defaults, you can change the size of the elements. For example, insert 1.1 and I press enter. As you can see right now the mesh is not visible because I haven't clicked on generate. After clicking on it, it will start to make the mesh. As you can see, it is getting worse because the element size was not okay. So you have to reduce it. This one is in meter, so I have to reduce it. I will insert 0.001 and then enter. Once again, generate. Now this is getting better. As you can see, the number has increased. So to check whether it works well or not, I will go to quality right here. You can check in the at first it's better to change the view. I will put it on aspect ratio. These are the options you can know whether your meshing is okay or not, and there are some standards perhaps for them. I click on aspect ratio. This is one of them. Doesn't matter what it means. You can see our video about it later, about aspect ratio and other elements. Right now I just choose it, and all I have to know is that the average must be near to 1. Aspect ratio average must be near to 1. So right here in quality, right here in mesh metric, I will change this one to aspect ratio, and now you can see some data about aspect ratio. The average is almost 1, so it's a good meshing. It can work us and it's okay. I will change the mode to skewness. As you can see, this is the skewness. I will change this one to quality, mesh metric, and skewness. Right now, as you can see, the number is so small, and a great number can be 0.33 as an average. It's okay, but it's so better. It's really small, so the meshing is great. After that, we will go to make some name selections, because Ansys must know every region of your model. This is the inlet. The water perhaps comes from this side, and it is the outlet. It exists from this side. These are the valves in our model, and this is the fluid part. So I have to name them one by one. I click on this one edge. I click on this edge, right click on it, and create name selections. I will type inlet. The software will smartly recognize the inlet if we type inlet right here. The next one is this one. I right click on it. I will go to name selection right here. Sorry, I have to click on it and then right click, created name selection. This one is called outlet, and then I press on OK. Right now it is time to generate the valves. I click on this, and after holding Control, I will click on this either, and then right click, create name selection. sorry, and I will type wall, as you can see. We recognize the inlet. Sorry, we recognize the inlet, we recognize the outlet, we recognize the walls, and here we have to tell the software where our fluid is. Right here, I click on this one, face, click on it, right click, create name selection. I can also press N. I click on this one and press N on my keyboard. It will show this one. I will press OK after typing fluid. Click on OK, and after clicking on generate, you will see that the name selection right here: inlet, outlet, walls, and fluid. All of them are named correctly. The name selection is completely done. As you can see, the meshing is great, and so we can go for the next part. I close this one. I right click on this, update this one. After updating, you will see a green tick right here, and as you can see, it is red. We cannot do anything. I will just wait to update the meshing. Right here in setup, I right click on it, I go to edit. It is time to tell the condition of our problem. Right here it will ask some question as defaults. We click on double precision, it will use 64 bits of your capacity, but if I do not click on it, it will use 32 capacity of your CPU. So I will just press on this one. I want to use 64, and this is the number of processor. For example, if I bring 2, 4, or 5, all of the cores in your system will work, and it can harm your system so seriously. So do not increase this one for such analysis. 1 is okay, or at most 2, and then I will press on start. And as you can see, the dimension here is 2D because our model was 2D, and you are not allowed to choose 3D. I will go to start and we'll wait until seeing this part of the software. It is loading. I maximize it and will wait until all of them are done. I have to wait until all of the process is done. I press on the OK. It was just some default asking for you to personalize your software. I will choose pressure based because I will choose pressure based because my analyze is not compressible. It's non-compressible actually, because as you know, the water going through a pipe is not a compressible fluid. So I will choose this one, and after that, here we have time. Your analysis is steady. The difference between steady and transient is that if the condition of your fluid changes through time, it will be a transient or unsteady. But if it's completely fixed, all the factors are fixed, it will be a steady one. As you can see, our problem was some water crossing a pipe, so it is fixed and it's okay. And these are for symmetry designing. Our designing symmetry, perhaps we could choose a half of our pipe. What I didn't, because it's not that heavy. If I use symmetry relations, it will reduce the amount of calculations so much. But here I chose a planner. And right here you can insert the gravity. As you know, the gravity is in y and as minus 9.8. Here our gravity is inserted, and after them I will check my meshing and then the report quality. You can see some factors right here: mesh quality, minimum orthogonal quality, aspect ratio, and things we checked already. Right here you can check also. I will go to models. I will open this one, go to the parts I need. My analysis is not a multi-phase. It's I do not need energy, because energy is activated when we want to know about the temperature or heating matters. But right here we just have viscose, radiation, heat exchanger, species, discrete phase, and all of them are not necessary for our analysis. We have nothing to do with them. So I double click on viscose. You can see right here different models. Because the Reynolds is less than the number we want, we can calculate. Look at this picture. I have calculated the amount of Reynolds, as you can see. So after knowing it, you can understand the fluid is laminar. So I click on this one, laminar, and then I will press on OK. Right now we will go to all of them is okay, just viscose was necessary. I will go to material. I will right click on the fluid. As you know, the default in Ansys is always air and aluminum, so I will change this one to so I click on new, and right here I can add any material I want. Using Fluent database is the most rational way. I click on it. Here there are different fluids, and if I want there are different solids. So because I don't want to change the material of the pipe, so I will choose the default solid of Ansys, and as a fluid I'm going to change air and use water liquid instead. I click on it. As you can see, different constant of water is visible right here. As you can see, that's okay. I will click on copy and close this one, and after clicking on change and create, I will close this tab. Right now you can see that water liquid is visible right here, and it has been added to our materials. The next step is to tell the software where our cell zone is. So I click on this one. I right click on it. I right click on it. I click on edit. As you can see right here, you are allowed to change the material you are going to have an analysis on. So I change it to water liquid and will click on apply, and I get out. Now it is time to tell the software about the boundary conditions. So I click on this one. As you can see, inlet, internal, outlet, and wall, all of them are visible right here. I will click on inlet and right click on it. So I will choose edit. Right here this tab is visible. According to the conditions of our program, our velocity is 0.0005, and as you can see, other options: thermal, radiation, species, DPM, multiphase, potential, structure, UDS, and so on. All of them are off. You cannot use them because at the first step, let me close this one. At the first step, you chose laminar, and you didn't turn on energy, as you know, energy equation. So these are not enabled for you. Just the things you can change is the boundary condition through these ways. As you know, we insert one another time. As you can see, there are some magnitude and direction. If I click on it, you can see that I can change the inlet and outlet directional velocity, but right now this is normal to inlet, so I will just choose this one, magnitude and normal boundary. The amount is right here, and in the inlet, initial gauge pressure is 0. We don't have any other pressure than the atmosphere, so I click on apply. So this one is, and perhaps this point can help you so much. Here there are different boundary conditions. As you can see, everyone can be used for some special ways. For example, outflow is and is not highly recommended most of the time. It is where you don't know about anything, the condition, you don't know anything about the conditions of your outlet or your outlet or your inlet. And for example, this one is pressure inlet. If you just know about the pressure of your inlet face, you can use this one. This one is symmetry. This one is pressure outlet. Right here our outlet is pressure. I will change the next. Actually it is the default pressure outlet. Here is exhaust fan, when you have a fan as an exhaust. Here is an axis. Sometimes you want to use symmetry or things like this, you can use axis. Intake fan is both for outlet and inlet. You can change if you want. There are different ways you can see our videos. I will record one about all of them and will speak about them one by one. But right now what we know is that we want to have a velocity inlet and know about the boundary condition of our outlet. So I insert velocity inlet, as you know, as I changed them before, and will continue. As you can see, outlet is right here. I click on it. The type is pressured outlet as a default. If I click on edit, you can see the options enabled for me. The gauge pressure is O because we assume that the water is getting out from the outlet, and the pressure will be definitely atmosphere. And as you can see here, there's a tick. After clicking on it, the amount of reverse flow will be 0, but we want it to be calculated. After clicking on apply, the outlet pressure, the outlet condition is completely okay. And in our example, the wall is completely fixed. It's not a stationary wall. It's not moving, it's not rotating. So all of these things, all of the defaults are okay for me. A stationary wall, not a moving wall. If I enable this one, these are 3 ways a wall can move. For example, it can be rotational or translational, and components, perhaps both of them at the same time. But right now we have a stationary wall, and here is a no slip condition enabled, and I will click on apply. I will get out. It's okay right now, and it is time to go to the solution. After going right here, this is solution. You can see that there is a tab right here called method. After double clicking on it, you'll see this tab. Right here there are different algorithm of Ansys Fluent. These are different kinds of algorithm. You can choose one of them for according to the complication of your problem. Right here, even simple can work for us. Actually, the equation Ansys is solving are full of round. For example, round u over round t and things like this. And these are some ways to omit the round and have some numbers instead. So right here you can choose a different algorithm to solve these equations. Some people ask what they are exactly. Perhaps it's not necessary for you to know in details the mathematics of Ansys Fluent. We are just here to use it, and all you have to know is that as much as you go down, the algorithm is more complicated, but it will help you better to it will help you about the convergence of your your solution. So I will choose simple. It's okay for our problem, and these factors as the default will work for me because it's not that complicated. The problem is not that complicated. If it was more complicated, I could change them and use, for example, quick or a third order muscle. But right here the calculation is not that complicated, so it's not necessary to change them. After that we will go to monitor. Here is monitor. We will go to residual. I double click on it, and here you can tell Ansys how close your answer must be. So I want to increase the accuracy. I will insert, for example, 0 0 0 0 and 1. I will copy this one and insert in the next one. As you can see, there are x velocity, y velocity, and continuity. These are different factors, and you want them this accuracy for solving these equations. I will click on OK, and the next step is to go to initialization. I double click on it. I will use standard initialization. So actually we want to start the calculation process from inlet, and we'll go through one cell by cell until knowing about every one of them. So I change this one to inlet, and as you can see, the conditions of our problem is here right now. We can see it. I will click on initialize, and you'll wait until it's done. After some moments, the initialization is done. So I will go to run calculation. This is step. I double click on it. Right here you have to insert the number of iterations. This is the number of repetition of solving. The much this number is, the higher possibility to have a good convergence. So I will insert 1000 because this is a 2D problem, and it's not that complicated. If I insert 1000, it will be okay. right here after all the process is done, we'll go to results and we'll choose this one. You can see that the convergence has happened. We'll go to contour, right click on it, we will insert a new contour and we'll choose velocity and we'll choose interior fluid because this is where we want to see the velocity. This is interior fluid, and we will click on save and display. You can see that right here you can see the velocity. It is higher in the middle and it is almost zero in the valves. I hope you have enjoyed our education. Please tell us any opinion you have in the comments, like our video, and do not forget to subscribe our channel. Have a great time and goodbye.